Okay, from our last section, using U substitution for the chain rule, we can list out a couple of derivative properties where U is a function of X. So we've been talking about how this works. What's important to recognize is that while U is a function of X can be written this way, also implies that if I have Y as a function of X, that in every one of these formulas I've written here, I can replace the U with a Y. It's just a different letter. Either way, it's a function of X. This is implicit differentiation's foundation. So with this concept, I can apply my U substitution in a situation where Y is replacing the U. Again, it's just a different letter, meaning every one of these, if I want to write the derivative of Y to the N, is going to equal N times Y to the N minus 1, and this is the key component, very, very key component, times dy dx. And again, I can do this for each and every one of these formulas. With that, I can handle complicated situations such as, let's take a look at this. So now, instead of having to solve for Y in this situation, I can take this using both chain rule and our normal power rule. So I'm going to use chain rule for a function and a chain and the power rule for the x squared. In other words, when I take the derivative, let me go ahead and color code this for you. So I'll erase this so you can see it in color. So when I take the derivative of x squared, it is 2x, and then 2 minus 1 is 1, plus when I take the derivative of y, assuming y is a function of x, then what I can do is take it as 2y, and it needs that extra step dy dx. And this is going to equal the derivative of 16, which is a constant, gives us 0. That means the derivative, all I have to do is solve for dy dx. So how am I going to do that? Subtract 2x from both sides. And then, of course, the next step would be to divide both sides by 2y. Simplify what you have, and you end up with negative x over y. So, this is an example of implicit differentiation completely founded in the concept of U substitution's chain rule. So again, implicit differentiation just flows from the chain rule properties.